All right, I'll pick up from the previous session itself. So what we were discussing, I mean, what we did, we just wrote a small program in PyTorch. We did write a small program here in PyTorch. Just give me a second. Okay, I did write a small program in PyTorch. And what was that program about? So that program was basically very simple, that I have this linear set of data. I have this linear set of data. And in this linear set of data using PyTorch, I want to predict, let's say, if I have X data and I want to predict that where my Y data is going to be. So we were actually trying to solve this. What we were trying to do is we did wrote a small program, although there was just one small error of zero that was causing the problem. Now these problems can be really tricky. And let me explain the problem also so that, I mean, whenever we face the problem, we can solve it. So I'll go back to the previous program itself. I do have shared the exercise also with all of you guys. Right. So here, going back again, I have provided this exercise book with all of the proper comments and everything. Everyone should at least go once, read it at least once. I have tried to list all of the important information. This is the point of a workbook. So yes, I mean, my PyTorch is already installed. My torch is already installed. And next is my torch.nn function. My torch.nn function contains all of the important ones, right? However, as of now, I am just concerned with layers function, that is nn.layer. There is just one function I am concerned with, right? And then I'm using random function. Random function is used to generate random numbers. I can also use random dot. There are few functions you can actually just try to play around. Let's say I can go with random integers if I want, between 10 to 100. So every time this is going to generate a random integer between 10 to 100, right? And then what I had to do is, I had to basically generate. As of now, first we are generating the data because we need to understand few concepts. Once we have the concepts handy, you have practiced it, then we can start loading the data, the real world data, right? So first we need, what we are playing with is a linear playground. What is a linear playground? If you go towards a linear playground, okay, I have provided its link. I mean, a linear data. What is a linear data? Linear data is like this. So you can go ahead, you can play around. What if you keep the y is equal to mx plus c, and m is here, c is here, you can go ahead and play around. I have provided the link also. This is just for general understanding. You know, you see this is the value, and how is this calculated? 1.4 of x, and x is this line and y is this line. This is y line and this is x line. So this is how the data is getting substituted here. And as you move this intercept c, this is where the line is going to intercept, and this m is actually the slope. So if you make the slope and you increase the slope on either side, right? So as of now we had to take something like from m or c. So I have taken c minus 5 m to noise factor, something b factor I have to take, and I am generating 100 points. So I'll go ahead and generate the 100 points. Okay, 100 points are generated. I need to just visualize that thing. I have added very little noise, right? I can go ahead and increase this, right? But first, we should complete the demos before we start playing around, because sometimes then it gets diverted. This we had already discussed. And then the other point being that as of now the data x and y is present. The x and y data is very simply, okay, I'll switch on to a new whiteboard other than this. Or maybe next time I can create my own whiteboard better, and then we can keep on saving it also. All right. So basically, the point being that what was what I was trying to explain here is that the data. So as of now, when I generate my data is present in, let's say, 1 comma 2 comma 3 comma 4, right? This is my data that is present. This is a Python array. This is a Python array as of now. The first requirement is I have to convert these Python arrays to at least PyTorch data. Why PyTorch tensor? Why tensor? Because tensors models can easily move between CPU and GPUs, and they are more efficient in calculations, right? And second point, basically, the data it accepts the data in this format. That is, this is one data. This is data number two, right? Two. This is data number three. This is how we are actually, it accepts the data into this format. So basically, it's very easy. There are just simple set of functions, right? So in TensorFlow, we just have a simple function to convert, that is torch.tensor, right? And what we need to convert X, and then all the data we will be using in float only. We do not do operations in integers because there is loss of a lot of loss of data. And then we unsqueeze. As we unsqueeze the data, basically, if you see, this is my X, first members of X, and as I have converted to float and I have unsqueezed the data, this is what it has converted into. It has converted into individual elements of array, we can say, or individual elements of tensor. You know, this is one data type, and this whole is data set. Now, if you see this thing, that what I'm trying to tell you is, see, this is one data point. This is one data point as of now, one data point, right? So hence it is trying to bifurcate between everything. And this whole is a data set. The complete set of data points is called as data set, right? This is complete data set. And then we will also have y, right? Y, we will, like whatever the value present here, we'll also need to uh, convert this y. So we also have this y gets converted, and this is my like x tensor. And same in the similar manner, I have my y tensor. Why are we taking this kind of data? The main reason being why we are taking this kind of data, because as of now we have this kind of data. In future, what is going to happen, we might actually, you know, I might have various kinds of data. Let's say if I have video, if I have a video, how am I going to represent? Definitely, video is also set of images. Video is a set of images. And one image we have seen earlier is again a matrix. It is again a number. So basically, you can convert a video again into some kind of array minus 2.x. I mean, this is going to be in float 0.02, something like this, something like this. And this becomes your input data. Then what about my output? Can I convert what is video generation? Yes, video generation also comes in a similar manner. How? That let's say my I need to generate my y. I need to tell my model that you need to generate this y, right? Here is, as of now, I'm just taking simple numbers. But in future, I can tell it that, you know what, your output is going to be a big long video or 2 minutes video. As of now, the best model VO is able to generate only 2 minutes video. We have various other models also that can maximum generate to 5 minutes or 7 minutes, obviously. So what it does is it will say that, you know what, you need to generate this in a video format. So first and foremost thing, the whole point being, we need to understand that every data in computer science can be converted into matrices, that is tensors, right? Every data is a matrix, right? 1D array, 2D or 3D or ND array. I'll talk more about it because there is this information still we have to discuss, right? Going back to this, creating our smallest model. Last time I had initialized it. I can initialize, I can choose to use the existing weights, but there is no harm even if we initialize this model. It is not harming us, but it has initialized with very small and uniform number automatically also. I mean, and this is completely random, it might be just following a random. By initializing with some static values, ideally, what happens is that you are fixing, okay, it is going to start from at least this point. Just an important thing that I guess some of you might be asking me, that what if I don't want to train it? Then what I want to do, I have initialized a model. Let's say m is equal to, I initialized a model that m is equal to nn dot linear 1 comma 1, and I directly assign weights that I had trained one model. I had trained one model earlier, right? And then I directly assign those weights to this model. I mean, I directly go ahead and set weights and fill nn dot bias fill. Can I do that? Can I do this? Yes, I can do this. The whole game is about learning weights and biases only. However, here this looks very simple because this is merely one neuron. This is just one neuron, very limited weights and biases. When the model is huge, definitely this also happens. But yes, there are complex functions for doing that. When there are billions of weights and biases that need to be updated, definitely you can do that, right? And this is what is basically the concept of even quantization happening. Now, let's say there is a big model of 7 billion in size. There is a 7 billion model, right? And it has various float points. Weights are in various floating points, like let's say 0.0000 and something, or 1 point so and so. Now I can basically, and these numbers are in multi-dimensional array, they're in multi-dimensional array. So this is what they are doing. If you want to run convert this model into small 1 billion model, then you can convert these big floating point numbers or multi-dimensional array into smaller array. You can convert this into smaller array, right? We will see this example also when we go towards large language models. We'll see how we can do all of these small operations. Obviously, we'll try on smaller models. So the concept remains same, right? We can transfer the model weights in this manner, but obviously, as of now, we are dealing with just one neuron, for our understanding. So we can do that. We could have done that, right? Next is the training loop. However, the problem here was basically we were going with this thing 0.01. 0.001 is the right value. I mean, basically, what is happening either ways, the what was happening, the error was exploding. Basically, the loss was getting too big. Basically, it was trying to update that loss very aggressively, and we call that problem as exploding gradients. And then before giving it to you, I did try this model and I trained it for what, 100 epochs, right? I trained this model for 100 epochs, and hey, hi team, can everyone put themselves in mute? Hi Prince, can you mute yourself? Okay, all right. Okay, I was at this, right. So basically, I'm training with 100 epochs, and this is it. It is the same program that I discussed yesterday. That first I'm calculating the loss, that is the penalty, and then basically loss dot backward, basically for upgrading the loss, and then here I'm getting the current weights, and then I am basically calculating the new weights by multiplying with the learning rate. This is where learning rate. So greater the learning rate, the more aggressively it will update my weights. The more the learning rate, more aggressively it will update my weights. Slower my learning rate, because this is the real formula that is there. you know So many a times these all small concepts become very complex. The reason being because in 99% of the books or videos you see out there, this is just a theoretical knowledge. Basically, they're not explaining it inside that what is a learning rate. Learning rate is a simple one-line equation, and there's nothing else, right? So basically, since they're not explaining, so it becomes very tough to imagine and even remember. You know, if you just see this equation and again and again, you know that what is the learning rate. Learning rate is nothing because learning rate is something how aggressively or how quickly your weights are going to be updated. That's it. And then we are updating these weights. Then we are updating these weights. And once we have updated these weights, we need to set our model gradients to zero so that, the problem of accumulation does not happen. So, I mean, the previous calculation or the previous weights don't accumulate. Every time every time new weights are calculated, they are updated, and we begin again and we begin again. Every time we calculate these weights and we begin again. So don't worry, we are not going to do every time all of these things. There is just 4 line of code after this, because but the whole point being, if I do not explain what is happening behind it, you will not understand it, right? And that's it. I have done this, and now it's time for basically testing our model. How do we test this? Basically, we go for model.eval. Before you start predicting, just switch your model to evaluation mode. Now, if you want to retrain it, either go for reinitializing the model or just set it to model.train mode, right? And what I have done is I have predicted the whole of the training data. I tried to predict whole of the training data, and I want to see that how has my model performed. We will plot it in a graph, but as of now, what we can see, model underscore predict underscore y of let's say 10th value, right? And then of, let's say, some 10th value is there, or I can print model dot predict at 10 to 20, right? I can predict this, okay? And besides this, I also want to see that what was my actual predicted value. So my predicted value was actually the real predicted value was present in train underscore y, and I'll go for train underscore y 10 comma 20. Now, if I compare it one by one, 19 and 18, if you see, now if I go for predicting one by one, if you now just see this, 19 is there and this is 18, close enough. 21 second, it is again 19, not close. 23, very close. 23, third one. 25 and 24, very close. 27 and 26, again close. 29 and 29, 31 and 31, 33 and again 32 point something, 35, same 35, but this is 35.01, this is 35 point, and this is 37, then this is again 37. So what we did was we did train the model that was, wherein we did train the model, wherein we were able to train it with quite high accuracy. The simplest ever example wherein we were able to train it with very good accuracy. There are some very important points that we need to talk about, right, before I go next on it. Now, what I have done is all of this predicted y, I will plot it against that original graph. I will plot it against this original graph so that I will see that my prediction, what is the difference between original data that is predicted y and this data. So basically it has learned it, this pattern, it has learned it. It was so, basically the problem is also easy, but the important points to note here is that I did not give any formula. I did not give any formula my model to learn. My model has actually automatically discovered the formula. My model automatically discovered the formula. It automatically discovered the formula, right? Now, this was no magic. Basically, it automatically discovered the formula. Right? This was no magic. Obviously, we did try to understand what was going inside it, but the other point is that how we have to first see and understand what my data looks like. Does my data looks like something like this? Okay. Or my data looks something like this, or my data looks something like this. Based on that, we will have to choose appropriate parameters. But that is not an issue. Even if you go commit some mistakes, then only you are going to learn. It is okay to write wrong things. It is okay to get wrong results. I mean, until unless you don't get wrong results, you're not going to get with it. So here I trained my first ever model, and actually this was a very simple one neuron model. This was a very simple one neuron model, right? Now the next problem comes in. The next is that, I want to basically, I am done with this data. This data is fine. I learned, my model is able to train this data out. The second thing, although this data is very simple, but still around 30 to 40% of the data, this is called linear regression. Linear regression, as the name suggests, linear regression. There is nothing bad into linear regression. I mean, when I say that, linear regression is still used in about 30 to 35% times. There are a lot of ways, there are a lot of applications where still this is used for basically forecasting in graphs and everything, right? But when you just want to use linear regression, right? Now, by also understanding linear regression, logistic regression, and all of these simple models, classification models, very simple models, you can also go ahead, you can start playing with a lot of things like tableau. What is tableau? Tableau is doing all of these things only. It is providing you the formula for doing all of these things, the ready-made drag and drop. You can go ahead, you can use, I mean, you can play around with tableau. Because now when we talk about data analysis, right? So you have actually studied how data analysis works, right? Now, I don't say that you have discovered all of the concepts, but yes, whatever the concepts are left, we will be covering them, right? And then this is the first step. You have actually gone for data forecasting, data forecasting or data analyst, right? Analysis and analytics, sorry. Analytics is where you want to predict the future. Analysis is you are doing all of the research on existing data only, right? And we have talked a stretch upon this. Skill is like pure gold. Once you have data and you have a target, that if you have meaningful analysis and analytics from this data that can give you some or more amount of benefit, then all of these processes are pure gold, right? uh, I mean, including the name, like, I have been talking to a lot of my friends who are in JP Morgan Chase, or big, you know these big analysis analytics companies, and I do keep on talking that what are you using inside. Believe me, it's 25% is linear regression still being used still, and this is never going to be outdated. But yes, linear regression has somewhat more points. That is, in real time, you will not have this data so simple. Even linear regression will have this kind of data. So let's do it. Let's discover that. You know. So let's first try that. What can I do? Can I just create the same? I'll basically start creating in the same notebook itself. This is again shared with you also. That is, we call this as non-linear regression. Very simple, right? Although this has too many fancy names also. which I will tell you later on that it is also called this. But as of now, we talk about that it is non-linear regression. What is non-linear? When the data is non-linear format, it is non-linear regression. When the data is in the linear format, it is linear regression. I did generated some of my data here, basically that was in this format, right? But now I need to generate my data in some other format, right? One, I will choose two problems here. We can choose any problems also, but as of now, I am going to choose two problems, right? Two kinds of data I am going to go forward with. One I will be solving, but one I want you to try your hands on. And believe me, there is just a small bit of change that needs to be made. Apart from that, there is no big, huge change that we need to make. So one problem I will solve and one problem I will leave to you to solve. Right. Now next, what I want to do is I will go ahead and I will generate some data that is basically in, let's say, I the more complex one I will solve and I will leave to you a less complex one to solve. But I will generate the data for both, don't worry. The first step is we want to generate the data, you know, that is in, I want, okay, I'll first draw the data that what do you want to solve. Okay, so this time I'm going and solving something as non-linearity, and I will choose substantial complexity data. That is, first I will choose again. I for now I will be generating the data. I want my data that is maybe present in this format. And what you will have to solve, you will have to solve the data that is present in this format. The process is going to be same. Both are non-linear data, right? Both are non-linear data. Now, a very important point before we go forward, why visualization of the data is important, because many a time if your data is having no relation at all, which is a very rare condition, although very rare, I mean ideally you have not selected the right data usually many a times, but if your data as of now you have not reached that, your data is not showing the right relationships, then basically first you need to work on data. First you need to work on data, right? Before jumping right directly to the solution, first you need to work on data. That we need to work, we need to find a lot of relationships between the data, and these relationships, ideally the whole world is running like this. There is relationship between each and everything, right? There is a relationship between the sunlight, the weather. uh, this is just for the reference, I'm telling you in the broader sense. The sunlight, the weather, this already we know. Sunlight and soil will have relationship. Soil will have relationship to our health. Soil will have relationship to the nature of the people living there. So there are a lot of such kind of variables that are present in this whole world that we can't even imagine, and this is an active area of research. Okay. So first and foremost thing, I need to go with this data. All right. So like I said, this time, so what I need to do is first I need to generate the sine data. Okay. So this time I will have to use, I because sine data, I can go ahead and have x is equal to, let's say 1 to 100, or I can go for number of data is equal to 100. But then for I in range of number of data, and then if I try x is equal to 1, x is equal to, x is empty and y is also empty. Now x is equal to I and y is equal to, import a math function. I'll import a math function and I'll use math dot sine, and sine of this data I'll store it here, sine of I basically. x dot append. I'll have to add it to my list basically, and y dot append math dot sign. Oh, okay. Although my data is generated, right? I'll just go ahead and visualize this data. Plot x and y on matplotlib graph. Okay, my data is also basically generated. Now, if I go ahead and look for this data, this is like a sine graph. This is how sine graphs look like. There are a lot of memes going around that there is no use of sine and cosine, but that's not the case. Your music wave and lot of waves, they are measured usually in sine, and there is a lot of application of sine. But anyways, sine and cosine are just for data conversions. We'll have a small discussion on it when we actually go inside, and basically we'll see how it is applied. Now basically this is the problem, that if I generate from 1 to 100, if I go, then there are too many waves. I just want one wave to track. I just want it here. So basically, there is another function that I will have to use. So instead of using this, right here, the things are very much random. I'll go with the import. I can even generate using this, but yes, I want to showcase this thing. So again, I'll go with number of data is equal to 100. I want 100 points, but I want it between -5 and 5. So basically, not everything is present in Python core. So there are other number manipulation libraries such as NumPy that is present. I have also written a note here, but I'll also explain you that when we use pandas is useful for visualization and manipulation, but is slow for computation. For normal computation, NumPy is fast as it uses C++ underneath for computation, right? And then last is tensors. All of the training of the neural network is going to happen in tensor. So ideally, sometimes there is a lot of confusion. In fact, 30-40% of the AI is about porting the data here and there itself. So there is one function using which I can generate the data. you know it is giving, so this is already giving me. So if I go ahead and line space, it is already giving me this data here. I mean, this will generate between two different points. Let me see what it is doing. It has already generated between 0 and 6. It has generated, right? I can go ahead and I can basically. Okay, team, when did I lose my connection?
You were talking about the computations of NumPy and pandas.
Okay, all right, just give me a second. I do not know why this happened. Okay, so I was talking here about these things. Hey team, I'm audible now.
Yeah, you are audible.
Okay, and what was the last thing I was talking about? This one, or we were at the line space function?
I think you are in the line space function, not.
Okay, all right. So all right. So basically, what I'm trying to do is I'm trying to generate the data between -5 and 5 because I need this kind of data. I do not need anything too much of fancy data. I'll just reconnect my session. Okay, so team, what it has already done is it has automatically generated the data between -5 and 5, right? And number of data has 100 data points have already been generated, and then I just need to convert it into y, right? And so it has already converted into y, and now this is I just want to generate between -5 and 5. I can go for -5 and 5 and whatever I want to wish, right? Now there is a very important point that we are discovering here. I don't want to make any changes as of now to my data. So what we do is I will copy paste the same program and let's see what happens. Let's see what mistake do we do, and let's see then how can we improve that, right? I have my data here. The next point being that I want to convert them into torch and float, and I have to convert them into this data type, right? So let's do it. I have x and y. So what I will do is I will train underscore x and train underscore y. Let me convert. Okay, so it is saying torch is not defined. Import torch. Okay, done. Next, what do I need to do? After that, the next function is, I'll just clear it so you can rerun it also. Next function was that model, right? I was talking about linear model. So let me just copy paste it again and let me see that what happens. Okay, I'll copy paste it again. One model, like one neuron. Okay, got it. Done. This is also no problem. However, and then this whole uh, we have the complete thing. I don't want to write all of this again, right? So what I can rather do is all of this has a complete automation in PyTorch. That is, how does it happen? Let's try out. Our first two things were basically we had epochs, 100 epochs that we need to train into. So like I said, this loop will remain evergreen with just small changes. So you need to be comfortable with this loop. If at all you have any problem for I in range of number of rounds, right? Number of rounds, right? First statement is going to be the same, right? That is prediction. And it is suggesting also first statement is going to be the same. That is about prediction, that right? And then loss. I'm not computing it anymore automatically, right? So rather what I will use is for I. Okay, so I don't want to take this thing like I don't want to do mean squared error was my loss, the MSE was my loss, right? I don't want to do it automatically. So basically I have a automated function here that I can use, and this automated function is basically just simply what we can do is we can use this uh, simple function, and we can just get ahead that how do we want to use our uh, losses. There are various kinds of losses that are present, right? We can use all of that. So I'll go with criterion and then dot functional.nsc. This is also one of the things that I can use train underscore y. So I can just go for train. I just need to provide prediction underscore y and train underscore y. It will automatically MSE means mean squared error. MSE means mean squared error. And then what we did was loss dot backward. This was basically, it is telling me that I need to go back and update my weights. uh, so this we did discuss in Saturday's session at length, that what it is telling about. And then after loss dot backward, I had to basically update. I need to tell that what we are doing, few things. Okay, do I need to tell this? Okay, optimizer dot stuff, and right, I just have two statements here. I don't need to do this also. Optimizer dot step, and that's it. But I'll have to initialize the optimizer. This is it. It is doing the same thing that we discussed here, that we had discussed in this video. I'll update the video and you can have a look. We discussed at length the basically, just for everyone's reference, like we are using, what we are doing is we are calculating the loss, and then we are calculating the weights, and we are updating the weights again. This is the same cycle we have been discussing n number of times, the same cycle of neurons, that we have neurons, and we have some initial weight, and it goes and predicts some value y, and then we calculate the loss of y minus y dash. We calculate the loss of y minus y dash, and then we go ahead and update these weights, right? And updating weights. So this is the same thing that we are trying to do here. Okay. The same loop can be actually seen like this. Just optimizer, we need to define this optimizer. So optimizer, I'll have to take the SGD function for optimizer, and let me actually will define it here itself. That goes as optimizer is equal to torch.optim.SGD model.parameters and model.parameters. I guess yes, this is fine. Torch.optim. Yes. Now we have done it. I'll just print the loss here. Print loss dot item. So as of now, I did not make any changes in it. So basically, again, going forward, first we calculated the loss, what we had did in the previous function. First, we calculated loss. After calculating loss, we are telling to update the loss back to our neurons. Basically, now let's call neural network the complete set of neurons that we have neural network. As of now, this is one neuron only, but soon in next example, we'll be switching on and then optimizer dot step and basically updating the weights. And once we have updated the weight, basically we need to set gradients to 0 so that gradients do not accumulate, so that they don't accumulate. And this is simply printing the law. I think there will be small error here because I have taken automatically this. Ideally, the syntax is not the same, but let's see if the new version supports this or not. Okay. So basically what has happened, it did learn, but if you see, it did not learn anything substantial. You know what? It has not learned anything substantial. So the loss is pretty constant. When the loss is pretty constant, it did not gives you any error, but the loss is constant. I want to see that what my model has learned. So how can we do is we can go for predicted underscore y is equal to model and train underscore x, right? And we can just put model dot eval here. We have set it into evaluation mode and I want to predict all my data. That is, I want to check, I want to plot it against the whole thing. Okay, predicted y is here. Now, just for your reference team, I have also updated this that whenever you want to plot your updated things, predicted y, whenever you want to plot it against yeah, whenever you want to plot your model dot predict, model dot predict underscore y. So basically this is, as of now, I'll take this code only. So model dot predict, if I check my type, what is the data type? Again, like I said, we are still not very advanced with AI. I mean, we are still evolving. This is a very early time of AI is servicing. So we still have to work with very low level things. So predicted in future, maybe what might happen, all of these data types here and there. So this is in tensor. Now for plotting we are using another library which is matplotlib, so basically tensors, like I told you, they're very in low level, they're attached to CPUs, GPUs, they really get attached and they occupy the memory. So the process is called detaching. So what I need to predicted underscore y, or I can go with model underscore predict underscore y, because my variable predict underscore y was used in training also. Predict underscore y was used here, right? So here is my model underscore predicted y, and I want to see that how, what has my model actually learned, what has happened. Okay, something is not right here. Model underscore detach. Okay, this is model predict underscore y is not defined. Why is it? Okay, this is fine. I'll detach dot numpy. Yeah, so basically this what has happened, it has converted back into my basically arrays. So I'll just take p underscore y underscore y is equal to this. Okay, and although this should not happen, p underscore y. Okay, what it has learned, what was my original data, you see, what it did learn and what was my original data, right? Now basically what happened was my data became incapable, my model became incapable of learning this kind of thing because I was using linear data only. Now the question comes that how do I, now, there is a very important concept hiding in here, right? What is that concept? You need to understand it because this will be the whole, you know, everything, a lot of things are going to depend on this. So what this concept is, let me switch to whiteboard. The concept goes like this, that, and you know, scientists struggled back in those days. They initially they were able to crack this linear thing. Initially they were able to crack this linear thing. Then what happened? They were like, how do I teach conditions? This is actually conditions. You know, this is what is conditions. Okay. This we are able to learn. This is very easy. You know, it may be this or it may be this, and this is also kind of linear data only, right? But when it comes to conditions, how does it happens? If I have to learn conditions, if you see, this is conditional. This is conditional data. Even this is conditional data. How do, or whatever you call it, how do you learn non-linearity? Non-linearity is also called conditional learning. Why it is called conditional learning? We'll have to think more deeply because this is also kind of, it mixes small philosophy also here. Conditional learning, if condition is this, condition 1 is this, then this should happen. If condition 2 is this, then this should happen, right? This is what is actually happening. If you see, if you have to just create this, you will say that, okay, if this is x and this is y, if this is y, you will say that, you will start writing conditions. If I tell you that, you know, if the x is less than this, then the equation changes to linear, but if it is at this place, then equation changes to a curved one. Then again, if this is the place, it again changes to linear, and this again changes to curved one, right? Although for demonstration you will say that, you know, I already have the formula for sine, I can put it in the sine, and I can evaluate. Yes, that is correct, but you will not have equation for all of the data type. You will not have any equation, you know, for this data type. Let's say if there is something like, something like this, you know, uh, you will not have any equation for this. You will not have any predefined equation to learn for this data. Or let's say the data is, this is 2D data, you know, I will also show you some 3D data also, three-dimensional data, right? Three-dimensional data, you know, how does it looks? It looks exactly like your mountains. We all love mountains. We go for holidays. You see those wonderful peaks going here and there, here and there. This is how your 3D data looks like. This is what is the 3D data. And hence I always say this is, I mean, this whole thing is very close to nature. I mean, see these mountains, right? Wonderful mountains, snowy mountains with snowy peaks. What does it return? It shows you 3D data basically. This is what 3D data is. We'll talk about it. I'll even show you graphically also how does this 3D looks like. Even when the models learn, it also looks like a mountain. It looks like a natural mountains and plateaus and everything. You know, this is how it looks like. So the point Anyways, the point I was talking about is that, what we are trying to learn here is, I want to learn about conditional learning. I want to teach my model condition that if X happens, then start going for this thing, that if anything, if condition 1, then do this, if condition 2, then do this, if condition 3, then do this. Now you say that, you know what, if this is what you have to do, why even write an AI? Very good, right? So here there was one question that was being asked in the starting of the session, that when to choose, that if you want to write rules or if you want to train an AI. So the answer is that, even then, that if you have limited conditions in your problem, that is, you can write 7, 8, 10 conditions in your problem, right? Then go for conditional approach. But if your conditions are increasing every now and then, number of rules are increasing, and you don't want to train them every now and then basically you will have to go ahead and train your AI for that. You will not be basically, you just need to train your AI and everything. So because I mean, if I say that there are 1000 conditions that I need to write down, right? I mean, it's impossible for humans. And even uh, condition 1 is connected to condition 787 condition, and condition 1 is connected to condition number 992. I mean, this is just impossible for any human to do that. I mean, we have limited brains. The God has given has limited brains, and we can only do limited stuff with that, right? So conditions, coming back to conditions, and this conditional thing, we call it that, how do we introduce a non-linearity? They came up with a wonderful solution to it. Now, it is not that this is the only solution in future, but till date it is the only solution that is available to us. In future, there is very active research that is going on. In future, maybe after, I do not know when the research is going to come, but in, let's say, 25, 30 years, or maybe after 100 years, we may not be even there. There might be some new research, and they might come up with even more efficient ways of this conditional learning, right? This might evolve, because it took, even to come AI till here, it took around 80 years. It was 80 years of research that uh, what we are learning right now. I mean, so this is a slow, and on top of that, I also believe that people back before 2000 were much more smarter than us. I mean, our generation. So basically, if you see all of the mathematicians, all of the physicists, the brilliant ones, I mean, they were back in 1930s, 40s, 60s, 70s. And you see all of the major breakthrough happens then. And then we have lot many tools, but yes, I mean, the number of breakthroughs have basically subsidized. So coming back to our point, conditionals. So what they said was, you do one thing, that here we are training the data, we will keep on training the data, and with the training the data, we add one more function after it. Let's say there is a neuron and it has learned something. Your weights are updated in this neuron, w1, w2, and w3. Your weights have been updated in this neuron. As your weights are updated in this neuron, and then after this, they said that let us add one more function, which we call as activation function. Why activation function we need? Because if we do not add this activation function, we will only have linear learning, which we do not want. The whole world is non-linear. Hence, for that, we need activation function. Right. Now, this concept might sound a bit weird. Concept is very simple, but why will it sound weird? Because how does it introduces conditions in it? I'll try to explain this thing. What is a activation function? Activation functions are like logical gates. What does a gate do? Logical gates, logical gates or switches, the board switch, board switch adds condition to everything. And the same way, even on the circuit board, if they have to add some logic, what they will be doing, they add lot of conditions with the gates. So we had already discovered these gates, and a better form of these gates became activation function. So one of the activation function is, let's say what we use is ReLU. We call it ReLU. What is this ReLU? This is graph, right? X and Y, and this is my ReLU function. I'll basically draw it better so that everyone understands it better. Let's say, okay, this is first my graph here, and then this is my ReLU function. This is my ReLU function. This is standard ReLU function. I also have a playground to showcase you this thing. What it does is, this is my x-axis, this is my y-axis. Now, let's say number is 1, 2, 3, 4, and 5, and similarly we have 1, 2, 3, and here we have -1, -2, and -3. Now, if the value is here, ReLU, what it is doing, it is a step function. Why it is a step function? If the value is below 0, it will shut it down. If the value is above 0, it will transform it into a linear function. That is basically, if the value is somewhere, the axis, the or the point lies somewhere here, the x is -2, then what is going to be, why it will shut it down. Or if x is 3, then basically it will convert it into a linear function. So basically, if it is positive, it will count it. If it is negative, it will not count. And even if it is positive, it will kind of somewhat amplify it. This is what is the meaning of this activation function. Now I have a small playground also, activation function. Here what I was showing you, that uh, note down this thing, that what it is saying, inner layer activation function, outer layer activation function, right? it, First is ReLU. What is ReLU? ReLU is no complex thing. This is what is ReLU. If input is -3, if input is -3, activation function is 0, shut it down. -3, shut it down. If input is -1, shut it down. If it is 0, don't count this neuron. If it is 1, it is 1. If it is 3, it is 3. And so on. Basically, only it is counting when uh, you know there is something, anything. So basically, if there is any positive value, it will count. If there is any negative value, now basically there are something. Even this also has this slope. So basically, you can change the slope of this ReLU, but nobody does actually. Even for even advanced level of research, this is happening. But for now, you will not need to. We'll go with whatever the ReLU functions by default PyTorch provides us. So we don't need to go for all of these things. But I'm just trying to tell you that these are very simple line functions. What we have been discussing, we can just change the slope of this line. We can change the slope of this line. Right. Now, I was talking about ReLU. Are there any other functions available? Yes, there are a few more functions available. It has Sigmoid Tanh. Linearity is linear. You want to be linear, but it will not learn conditions. What is the Sigmoid and Tanh? Just like ReLU, these are also functions, but we'll have to discover them and we'll have to discuss them. Sorry. Right. So let's first use ReLU and first solve our problem, then we'll talk about it. Now, also, there is one more addition, that, okay, along with ReLU, I also want to now complicate my model. This was my model. Okay, not anymore. I don't want to use just one neuron. Basically, what I want to use is, I want to make my neural network a big, uh, I mean, a bit bigger. So for very simple, I will just first write them, because I mean, I'll have to stack these neural networks. We have been talking a lot about that also, that a neural network, what it is, this is stacking, right? Stacking of the layers. This is what it is. So if you see, this is somewhat, this is in sequential manner. This is in sequential manner. Yes, it is in sequential manner. I can stack my layers. I can stack my layers when I have to make my neural network better. But is it that every time I have to stack my layers? No. Extremely complex models not always stack with each other. Extremely complex models. But for that, we will see it differently, right? We'll come to that point once we are there, right? For as of now, I want to stack my layers. As of now, I want to stack my layers. And in fact, most of the problems can be solved by stacking. It is only when we go to very advanced models, we'll use them. But yes, for now, we will go with the stacking of the model. So for stacking, what I need to do is basically I need to set this model. You know, I'll have to attach more layers to this model. Give me while. Okay, anyways, no worries. So what we'll have to do is we'll have to stack these models. So I can even go here and say that, you know, generate a sequential model with linear layer and ReLU function. I can go. So what it has done, this is a very standard model. So I'll just copy this part. Basically, what it is doing. Okay. Now I don't want to use this linear layer anymore. But now I have few more things. I have one input layer. I have used hidden layer also this time, 10. But this 10 should be same as this 10, because you know the layer you will have to keep the same. The data should flow. And then in the end, there is one output. There is one input, there is one output as of now. If you would have two out inputs, then we would change it to two. Now remember that example of housing where we had 8 inputs. So as per that, we managed that. But output was there one only, right? So can you have multiple outputs? Yes, we can have multiple outputs, right? So as of now, I have taken 1 comma 10, and this is it. This is the only change that I want to make in my model. And I'll go model is equal to nn dot sequential. After linear layer, I have added a ReLU function to it. And then again, my last output layer, this is my output layer, this is my input layer. I have 10 hidden neurons. What I have, sorry, 10 neurons in hidden layer. I have one hidden layer, and in that I have 10 neurons, right? Okay, anyways, sorry, right. I'll go ahead and I'll execute it. In fact, I'll execute from starting itself so that nothing goes wrong. Okay, this is right. My data is right. Oh, all right. And then again, I go for unsqueeze. I create a model. Okay. And this thing is going to be same. No change in it, right? Okay. But again, I guess it is not very much learning because the loss is there. But let's try to find out that what it has learned. Okay, it did learn something, right? Which is non-linear in nature. What should I do? I should train it to more. I'll go for 1000 maybe. You know, I'll go for 1000. Okay, the loss has further subsided. Let's check. Let's check. Let's check. It has learned even more. But is it like fine? What I can do is I can increase this 20 a bit so that you know its learning capability increases, and this also I'll increase to 3000. Okay, The loss has further gone down. Let's check. Let's check this time. It has actually gone bad. Let's check what it shows now. It is trying to learn, but it is far away still. So I will have to increase my, it is learning, but I think so. Instead of SGD, I will change the optimizers once. Because I doubt optimizer. Just give me 1 second. I'll have to. Optimizer is fine, I guess. Learning rate is also fine. And then go for. Okay. Okay, the loss has gone even down now because my updation function was too big. And now, all right. So here we are. Team, are you following? Okay, cool. So here we are. What we did was, now if you see, it has learned everything. In fact, just a bit here and there. One more important point that we come to is AI is not about approximation. I mean, AI is not going to be 100% approximate. AI is about probabilities. But yes, just using this theory also, we solve a lot of problems that were never solvable by normal computer programming or something like that. So yes, but if you say that, whatever I see every time, let's say if I want to predict this value somewhere here, I am here, my real value is here, but I will be close. I am going to be close. Yes, I am going to be close, but it is not going to be exactly the same. I will be close, but exactly same is not possible at all. Either you keep on training, and lot of data you train out. Uh, so even one more problem is here. I will later on introduce you. You should not be increasing too many number of rounds of training because then it will learn your data by heart. I have now done for 1000. Even even you see, even for 1000 it works. The only problem was just learning rate, because too much low learning rate, it might cause a problem. Let me check with 100. What is it? Even with 100 now it is performing fine. Yeah. Yeah, with 100 also it is performing fine now. The only problem was learning rate, because if learning rate is too low, if learning rate is too low, you know, my model will be updated very slowly. And what does it means? I will have to train for very long time. If my learning rate is too low, my model will be updated very slow, right? So and then you can go ahead and, let's say if you want to predict any on any training value, let's say for 2, let's try, I'll just try to predict for 2. Okay, I have train underscore x of, I'll try to access some, I have 100 data points, I guess. I'll try to access some 80th data point. This is 3 point something, right? If I want to predict it, how do I predict it? Model, or prediction is equal to model, you just pass, but you should be passing the right tensor here. Train underscore y 80th, sorry, yeah, train underscore x 80th value, 80th value, right? What is the real uh, value here present? Train underscore y of 80th. Let's find out what was the real value. The real value was, targeted value was 0.067. Is it the case? 0. Yeah, 0.067 somewhere here. 3 for 3 is somewhere here, and 0.06. Okay, this is a tensor, I guess. Hold on. Train underscore x, train underscore y. Sine is here. Mm, okay, and if I predict it, p 0 point, now 0.0350. So this is the point here. Now here point, basically the point might be somewhere here or here, and this point might be uh, near to that point. Yes, Q.
Anand, I heard two questions. The first one, as you said, right, we should keep the training rate low. So not sure I'm asking here the relevant question or not.
Right, right,
But
sure,
if
sure.
we can consider that yesterday the Balaji has asked that one scenarios for
Right,
his business use cases, right? They have
correct,
a multiple rules
right,
and they have a data. Definitely, he looks like it's working on the enterprise company. Definitely, they have a more data, right? So
correct,
in
correct.
that case, if we can keep a rate low for training data, then how in real time that we can interact the actual model to our business application, right? In that case, we need to keep giving the data to our model, and also we require the output to our business application as well, right? So
Right.
how, what are the best practices, and if this is not a right time, you can also give me the later on
Yeah,
this
yeah. I mean, I'll very briefly explain it. So basically, yeah, first and foremost thing, in reference to the same point, what we are talking about is the learning rate. First, what we are talking about is learning rate here. First, we need to get this thing clear, right? We are talking about is learning rate.
Hmm.
Now, what learning rate? Basically, the rate at which weights will be updated. The weights are getting updated, the rate at which the weights will be updated, you know so this is point number one. Now, in real time, the rate cannot be too low. It cannot be too low, because if it is too low, then what is going to happen? It will take forever to update my to train to do the training, or it will, if let's say 100 epochs, this data is very low. Ideal in real case, 100 epochs might take one day, right?
Yeah.
While what about 10,000 epochs? It might, in that case, it might even go for like what it is, 100 into, if it is 1,000, I mean, it is like so many more days, isn't it? Like, it is almost like it is going to take 2 3 months in that case, right? So basically, again, if we are training for too many epochs, the training is happening very slow, very slow, very slow. It will take a lot of time, and time means money. Basically, we'll be burning more GPU. But also, if it is too high, so if it is too low, if it is too high, then basically what might happen, it might never be able to update the weights. It might never be able to update the weights properly. That is, the learning rate is, actually the whole point of learning is that, let's say I'll still have to go to this concept. So learning rate somewhere, the weights are somewhere here. This is basically the loss curve. You know, you need to get, so it, what it is doing is, it is trying to minimize the loss. The loss should be minimal somewhere here. Ideally, this is the ideal point, that loss should be zero. But yeah, I mean, loss zero doesn't happens most of the times for complex data. So my idea is that I should get to the at least to this point. So one task is I can go for one like this, like this, like this, like this, like this. So it is going to take me forever. If I take too much of uh, big loss, it might go here, then it might go here, it might go here, or it might not even go here. Again here, again it will try to go here, again it will try to go here. So ideally, we have to. I'll show the visualization also. Even with this implementation, we have made a lot of mistakes, but that is okay. I want to go into the natural way. So basically, ideal case is that. So what is the ideal case that we should be training? An ideal learning rate that we have to find out as per the data set. We have to experiment and find
But
out. So I, yeah,
yeah, but data set would be the larger, right? In that case, it will take some time to like that number we need to find, that
yeah.
will take
Or
time so for
even
us as well.
finding the number, you can first take a small subset of data set, right?
Okay.
You don't
Okay.
need to just jump in with a huge data set. Let's say if you have 1 lakh records, right?
Yeah.
You can have 1000 records first, right? And then you can establish everything. Okay, these are my best hyperparameters, and then using that, we can go ahead with the bigger data set. So
Okay.
basically, we'll have to experiment. First, we'll have to take a small data set, 1000 or 2000, whatever is, and then we do all of our experimentations that, okay, this is learning, getting fine. This is my learning rate. At this learning rate, it is getting fine. Second, we can go ahead and use AutoML also. What we have learned, that is, you set the systems in the night, right? And you say that, okay, on Friday night, I'm giving you this task. I will meet you on Monday morning, and you get me all the results ready. This is also one lazy way of doing that. But yes, the best way is that we monitor and we try a few points. We observe the graphs, that how our learning is happening. There are certain tools that we will use, basically like tensor board. We will learn to use how to use tensor board, for learning all of the advanced things, like how do we visualize that this training is happening. I can show a small, I had downloaded somewhere, but yeah, I'll have to search. So basically, on tensor board, we can visualize that how this training is happening, what my loss is, and some, if my learning rate is too high, we can get to know. If my learning rate is too low, we can get to know. So basically, we will have to dissect how the model is learning, right? As of now, we just learned how to train a model.
Yeah.
I hope
Okay.
that answers your
Yeah,
question.
yeah, I got it. And
Cool.
second question, actually,
Right.
the ReLU activation, right? The
Yes.
function, is it only applicable for the nonlinear, uh, the like kind of situation, or when it can be used?
Yes. Yes.
I'm just
Coming to that.
required
Coming
more. Yeah.
coming to that, yes, we'll come to that. We'll be having discussion, because these are very important. And I'm not this is not the first, or this is not the last time we'll be discussing these things. Because once you have command over how neural network works, you have command over how you can build your own neural network. Once you have command over these activation functions, believe me, you are better than 70% of the people already that are in AI, right? You're already better than them. Once you have all of, when you're talking, if someone is coming to you, if someone is telling you what is ReLU, right?
Mm.
You tell them, you know what, I let me draw it. This is a step function. This is how it works. You are better than 70% of the people, right? You have already cleared that. But I'll tell you a big problem with AI, a big, big one. These concepts you will forget in 3 days. After 3 days, if I come back and if I tell you, can you tell me what ReLU was and how does it work? What is the function of ReLU? What is a step function? What is conditional function? You will forget it. This is the most biggest problem with the AI theory. So basically, the only point being that whatever is happening, at least bring the theory once in 7 days, 8 days, 10 days. Have look at the theory once, prepare some beautiful note for yourself, or I'm also trying to basically come up with some Anki cards, but it will take me some amount of time because I know this problem. uh, you will have to Anki cards are basically small cards wherein you can just swipe right and swipe left based on that, and then you can revise your concept. So already whatever you have learned, first, if we are able to retain that, that is a big, big success. So we will be learning everything that is going on in this AI world. The only problem will be retaining this knowledge. That again becomes a big, big, big problem, because most of the times, let's say, even if you're trying to go with anyone, you're trying to upscale yourself for some AI job, project management job, or because the biggest problem is project managers don't even know what AI is. Now, even for the functional people, uh, it all this theory now, this will give basically wings for your brain. You can think that what this AI can do, where my product can be next 2 years, where my product can be next 2 months. What features do I need to uh, get out? I mean, release out. Sorry. What are the new features that I need to release out? So it may be for anyone, job seekers, for internal. If you want to upgrade it yourself internally, or if you want to upgrade yourself intercompany also, and whatever, or even for investors. So this all theory is very relevant for all of the founders or anyone or want to be founders. For anyone, the only problem is this is basically so much out of the, I mean, till now, actually your brain starts tricking you, because till now what you have learned, you have seen that everything is approximate. When you multiply 2 into 3, you have the sum function in Excel, and you have a lot of functions in Excel. All of them give you value in approximation. But the real world, now if you try imagining everything, you do not know what is going to happen tomorrow, although you have probability of few events that can happen tomorrow, but there is nothing certain about it. There is nothing certain what US is going to roll out with policies. There is no certainty. But can you actually predict that this can be, these are the probabilities? Yes, you can do that. The beauty of AI, you can do that. That what US, because these and these conditions are forming, due to these and these conditions, US can come up with mostly these policies, right? So these kind of things, this is the probability based whole uh, theory and practical. So you will have to get accustomed to it. This is the only problem, right? Going forward, we'll discuss about ReLU and other activation functions. Now, the point you asked was that when you have linear data, then obviously you may not need it, right? Even if you add it, there is no harm. It is not going to harm you out, right? Because there is no condition. It doesn't have to learn any condition. Ideally, like I said, if this is the data, why do you even need to apply AI? You can directly put it into y is equal to mx plus c, and you can get it sorted out, or even Excel can sort it out. Excel can do the prediction and all of it. But the real challenge is this thing. This is the data. And now if you go back to Salesforce, you go back to Excel, and you try to visualize some of the Excel sheets that are present normally with you, the business Excel sheets, the kind of projection of Excel sheets, inventory sheets, or any kind of business that is going to happen. This business might come, not come. The projection of the company, it is happening in this manner only. So theory that we learn, it has lots and lots of applications. It has lots of applications in real world, right? This nonlinear regression, what we call nonlinear regression, it has lots and lots of applications. Now you can actually solve that problem of housing also using the same thing. The housing problem can be solved using same thing, right? uh, what we had done, and we will do that. We'll solve that this housing problem, but I'll just write the solution in the notebook and we'll quickly walk through, right? So using this theory only we can solve the housing problem. You will only need ReLU. Now ReLU and Tanh, these are two activation functions that you will need when you need to make your model learn conditional. Conditional learning, whenever you have to do, you will have to use ReLU or Tanh. Remember this name, remember this name. Internal only, internal only. What do you mean by internal only? Is it something that we can use outside the model also? See, there will be activation function that will be used in output layer. These activation functions are used in middle layer only. They will not be used in input layer, not be used in output layer, because middle layers are the layers that need to learn the conditioning, right? They need to learn about the conditional things. Now what you can do is you can go ahead and first and foremost thing, I want my team to go ahead and I will give you a task. Basically I will write a small function once I give you, right? And that function is basically I will give you this data. This is the data that I want. I will give you this data. So my data will be present like this. So this is, sorry, it will be present like this, right? Try to solve this data, try to run on this. I will give you the complete sheet, don't worry about it, right? I'll give you the complete visual, even I'll give you the program to generate the data, although by now you should be able to do it. Try to do it yourself, but that is okay if you're not able to do it. I'll give you this program for now. Ideally there is no change for this, there is no change for doing it, because it has one input only and it has one output. Output is one, input is one. Ideally there is no change in the program, just x and y are going to change, that's it. But I want you to do it, do this thing. If you have any problems, do ping me and we will sort it out. Don't worry about it. If you're not able to run anything, don't worry about it, but making errors is mandatory. The moment you feel that, oh no, this is so complex, I'm afraid of it, it has taken over you at that moment only, right? So you don't need to be afraid, just go ahead and just do it, right? This is the only way you are going to learn AI. And step number 3 is, once you are comfortable with it, these are small snippets of code. These are small single lines. Just go ahead and start typing it. First just look at it and basically start typing it. Just do this thing. After 1 to 2 months you will see that you don't even need to look at the notebook. And if you're thinking that, oh, I need to remember it, don't worry, everyone in this world needs to remember them. If you go ahead and even watch the videos of Andrej Karpathy, right, the biggest, I mean, the person who actually created chat GPT, even if you go ahead and see his videos also, he also forgets syntax. So don't be, there is no point in uh, saying that, oh, I forget the syntax. Do I remember all of the syntax? No, I don't remember. Let me be very frank. After working in AI for 8 years, even I forget the syntax. Now, but what, obviously, what if I'm doing it day and night, I remember it. So there is no, I mean, forget about it. You know, don't need to remember the syntax, but practice it so that you remember most of it. This is the only point, right? So this is an activity that you will have to do. This is an assignment that you will have to finish. I'll give the complete details of assignment in the exercise book. You know, in the same exercise book itself, I will write down what is the assignment and it needs to be finished, right? Anyways, coming back to the same points that we had discussed, the same points that we have discussed. Just give me 1 minute. I'll just have a water break. So we have a small pending discussion on more of activation functions. So it is this activation function that is actually providing you, that is actually giving you all of this uh, conditional learning. You know, these are these activation functions. Now, uh, as of now, we are working with 2D data only. Like I said, we are working with 2D data only. There is more 3D data also present. You know, we'll soon see the 3D data, how to work with 3D data and n-dimensional data. This is what is images, audio files, text files. And this is what the n-dimensional of data, and just more amount of complexity in the layers. When number of layers increase, then obviously even uh, GPUs also increase and everything increases. Yeah, but till that time, ReLU and Tanh. We discussed about ReLU and we discussed about Tanh. What is the difference between them? When to use ReLU? When to use Tanh? Right now, I will just go ahead, and what I will do is, shall I try to add here Tanh? The best way to maybe remember it. Right? Let's try to do it. Right? But before doing this, remember this, or I will save this. Then I will. Okay. ReLU I saved. Right. This was the graph, a sharp graph that I got with ReLU. Right. Let me go ahead with Tanh. I guess it should be in camel case. Eh? Yeah. All right. Tanh. Right. Next, what I do? Okay. It runs. Great. I'll load the data again. I'll do it again. Okay. And then, okay. I create this. Number of rounds 100. Actually, I can keep it first 50. Let's try what happens with 50. Okay. 50 is there. It did not learn much with 50. Tanh did not learn that much. Actually, did not learn anything. Okay. So with functions, a lot of things change actually. Yeah. Anyways, I'll have to increase the epochs. I'll increase it to 1000 directly going. And yes, the error has gone down. Loss has gone down, sorry. And here we get. And so, okay, this one also learned. Let me save it down. And tell me the difference between these two. Now, I will just open them. Tanh and okay. Okay. Here being this one is the Tanh function, and this one is the ReLU function. This one is the ReLU function. Can anyone tell me what is the difference between these two? Can you tell me the difference? See, I told you once that graphs are very subjective.
Looks like damage is a more accuracy is nearby our original data. That what I'm observing.
Correct, correct. That being yes, somewhere it is. So basically, if you see here, Tanh learns through sharp edges. You know, the edges of Tanh is sharp. You see the sharpness here?
Mm.
You see this sharpness here? You see this sharpness here? And see the smoothness. See the smoothness of tanh. It is smooth, smooth. At curves, it is very smooth. No?
But yeah, the other difference also, Anand, I can see that in ReLU we have a uh, the the training rate, right? It's also differ than
Yeah,
the.
we'll have to play. Actually, we'll have to see that. Basically, yes, we did train with different. For benchmarking, we'll have to keep these training rates same, and then we'll have to compare. Right? I
Mm.
guess ReLU got trained very easily as compared to tanh. tanh did take some large amount of time to train,
Right.
and also, you know what? ReLU specializes in you know some of the corner cases, we can say. So ReLU specializes, and basically when you have to train your data more of in the curved manner or something like that, then this is where the tanh comes in. Now if I go here and if I see this was my ReLU, and what about my tanh? The tanh is curved function. Tanh is a curved function. So what does it do to minus function? It is not converting it to zero. you know it doesn't convert my functions to zero, right? So basically, even if you see, the minus 3 is going minus 3 is not getting converted, minus values are not getting converted to zero, zero is only getting converted to zero, and then so on. So it is treating minus negatives and positive uh, somewhat similar way. Now, the point being, can it play any role in my training? Yes, of course, it plays a lot of role in your training. So basically, I'll have to basically go and check, but I think so. The larger amount of training was because there were larger number of noise that was present, because a lot of negative values are also getting counted, and hence it has to go through lot of computation to learn that data. The reason being because even this negative data was getting counted, right? Whereas in case of ReLU, my negative data is not getting counted, only the positive data is getting counted. But the point being that, is it the case that will ReLU outperform everyone? No, it depends on data set to data set. We will discuss more about on some of these cases as we go forward, wherein we will see that in some cases uh, tanh will outperform ReLU, because it depends on the data. Whereas in most of the cases, you can use ReLU. In actually 80 to 90% of the cases, you can go ahead and use ReLU. ReLU works the best, but ReLU only works in your hidden layers only. What about this output activation layer? There are more activation things, but this we will have a look in the next section, because I don't want to confuse unnecessarily that we jump to some concept that is still we did not even visualize that data, right? Now again, the same thing basically, that what is happening here, this is my nonlinear model, this is my nonlinear model, and this is my ReLU function, right? And this is my data type is, let's say, quadratic, the problem that I gave you. If you see, if I go for next step and if I go for learning ReLU, how does it learn ReLU? See, it has formed a curved first, sharp curve around, and then see it fits. This is how it fits. The ReLU, how it has fit. Okay, all right. What about tanh? Let's find out what happens with the tanh. No? And here you see, so it has taken some larger amount of time to fit this data. ReLU was very quick to position in this data, and it has taken really large amount of time, 656 epochs. Whereas with ReLU, it was really quick. So hence this is the function. This is my sigmoid activation function. I'm also plotting this loss here for visualization, that loss, and 656 was number of epochs it took for tanh. Let's find out for ReLU. ReLU is this step function, and I'll just go ahead and press the enter. Oh, really quick. And now just very close. How many epochs? 90 epochs. That's it. And loss also, if you see, loss has gone down very quickly. The reason being, I mean, obviously, when there are less number of, it eradicates one unit completely. It eradicates that. But going forward, what about if I have sine function? What about this? Let's find out. We'll first go with ReLU. Okay, ReLU in this kind of thing. See, ReLU is learning edges. ReLU basically learns edges, and ReLU is learning. Now the data set was complex, and hence it is taking more amount of time, but again it is learning, and it has learned. This is where I see 780 epochs. The number of rounds are not static. It will depend on data to data, right? But if you see the loss is not very smooth as of now. I mean, it should be this way. Loss is not very smooth as of now. What about tanh? Let's find out. Okay, tanh is, I guess tanh is even struggling more. tanh usually learns curves, and since there are more negative numbers also, so it will definitely have double load kind of thing, you know. Okay, it is still learning. And this is what we also saw, when we were, and now, okay, now it has started acting very quickly, and after a point it did learn. Okay, and it has fit it quite well, but yes, it took I mean 1500 epochs, whereas it was just 700 epochs for them, right? So this one more function called as sigmoid, but do remember tanh is s. Actually sigmoid is also s, but sigmoid s is above negative only. It is just above zero. Tanh is usually, tanh counts the negative values also, right? But sigmoid doesn't count any negative value. The reason being this: if I just go with this, it is even slow. It is even lot slower. Usually we do not use sigmoid. So basically, either we will use ReLU. So most of the times we'll use ReLU, and then we'll use tanh in some of the cases. But we'll have to find out that what are the cases wherein we use ReLU and what are the cases where we use tanh. And similarly, I have, okay, these are the two things that I made. The output layers, will have to learn them basically when we use output layers. Maybe in the next classroom itself we'll be exploring them. Here okay, here again we have linear is linear, and there's nothing. Tanh is basically this is tanh, and sigmoid is again one more function, but again for sigmoid, for negative it is counting, but it is counting very less. So I hope this all thing became quite clear to you, everyone. Team, is it clear for everyone? Okay, cool. All right. So, team, for today, I will keep the session limited for this only. The reason being, there are some things that you have to practice, because obviously exercises that you will have to practice, and I just have to give you this thing. Okay, exercise 4, I have already shared this exercise 4, which we already did. I guess I have already shared it with everyone in the WhatsApp, right? I'll also share it. again. And there is one assignment that you need to take care of. The assignment basically is create model for parabolic data. I'll just generate the data for you here. I'll just generate the data and send the link again. And then you will have to just, you can, instead of this time, first at least try to run the exercise 4 first part, that is, we were trying to write this whole thing ourselves. If you have time, then at least try to rewrite this function here, you know because what we have done here is we did skip all of the complexity that we had written manually. This time we did take everything automated. I mean, that is from the PyTorch function itself. And then we went for prediction. So that's it, I guess. We can now go ahead for how do we go for nonlinear functions. And then going forward, next is basically we will pick up next session is that, because the next session again I'll have to switch to a new topic. So the next session is about how I do need to start with more external data sets, first and foremost thing. And third thing is, first we will start with text data sets. So the next week is completely going to be about texts. Now before that, yeah, I mean, I'll have to cover how to basically start uh, differentiating between the data, that is classification problem. Till now what we have covered is linear regression problem only. The next problem is logistic regression. So we'll have to cover the logistic regression problems. So yeah, team, anything else from you?